Here is another example with two-port networks. So here the given parameters are H parameters. We have H11 equal to 2 kilo ohms. H12 doesn't have any unit, which is 10 to the power of minus 4. H21 is 100. H22 is 10 to the power of minus 5 Simon. Okay. So in this circuit, he's asking us to find the input impedance. So we know that impedance is nothing but V1 over I1. So as long as I have a relation between V1 and I1, so say V1 equal to say 10 I1 hypothetically, so V1 over I1 will give me 10, which is the input impedance. So that's what so at the end of the sum we need to come up an equation something like this. So that's what we're trying for. So to do this, you have to remember these formulas for H parameters. V1 equal to H11 I1 plus H12 V2, and I2 equal to H21 I1 plus H22 V2. Here H11 is short circuit input impedance. So H11 is short circuit input impedance. H12 is open circuit reverse voltage gain. Open circuit reverse voltage gain. H21 short circuit forward current gain, and H22 open circuit admittance. Those are the H parameters. Now here, similar to the previous example, what are we going to do? Since H parameters are given, I'm going to substitute those values. When I substitute those values, V1 equal to 2K I1 plus 10 to the power of minus 4 V2. That's my first equation. And I2 equal to 100 I1 plus 10 to the power of minus 5 V2. Okay, so these are the two equations we got so far. But we have 4 unknowns, so we need to come up with 2 more equations. Okay, so as I mentioned, we have 4 unknowns, so we need to have 2 more equations to find out those 4 unknowns. But our goal is not to find those 4 unknowns. Our goal is finding a relation between V1 and I1. So I think 1 more equation is good enough, because the 4th equation for the circuit kind of hard to derive at this point. So the last equation, the 3rd equation I'm going to have as I'm going to apply KVL here. So V2 equal to minus 50K I2. Okay, that's a resistive load. I2 must enter the positive, then it will become positive. But here, if I2 is in this direction, then V2 equal to 50K I2. But I2, he gave us the direction, so that is the reason you end up with a negative value, negative 50K I2. Okay, so that part is important. Most of the times you made a mistake there if you do not have enough practice. So what I'm going to do, I need a relation between V1 and I1. So I'm trying to eliminate everything and put it into V1 and I1. So here what I'm going to do, I'm going to substitute V2 in equation 2. So substitute equation 3 in equation 2. Okay. So here basically, we have all these 3 equations. That's you almost have the final answer, but at the same time, to get the final answer, we need to do some mathematical analysis, solve these 3 equations. So that's what we are doing here. So here I'm substituting equation 3 in equation 2. So here is my equation 3. Equation 2, I substituted V2 equal to minus 50K I2. So V2 equal to minus 50K I2. We will end up with 1.5 I2 equal to 100 I1. So I2 equal to 66.67 I1. So now I'm going to label this as equation 4. Now I'm going to substitute equation 4 in equation 3. So we'll end up with V2 equal to minus 50K times 66.67 I1. This is equation 5. Now we're going to substitute equation 5 in equation 1. So here is my equation 1, here is my equation 5. So if you substitute that, then we'll end up with the relation between V1 and I1. So I'm substituting here equation 5. So here is my equation 5 in equation 1. Here is my equation 1. When I substituted that, we'll end up with a relation between V1 and I1. So V1 equal to, I have 1666.67 times I1. So V1 over I1 will give me input impedance, which is 1666.67 ohm. Okay, that's it. This is another two-port network example with H parameters. Thank you.